So what I want you to do for homework is topic number 6, topic number 7, okay? And then we'll also do topic number 8, okay? All right. So I'm going to go through this with you, right? In fact, I might even just make this a bigger, right? Because just so that you can see what's going on. Now, y equals to x, right, is what sort of a curve?
Straight line.
Straight line with a gradient of?
1.
Passing through the?
Origin.
Origin. So yeah, it's kind of look like this, right? X squared will be a?
Parabola.
Parabola passing through the?
Origin.
Origin.
Concave up or concave down?
Oh, concave up.
Yeah. So it's kind of going to look like this. Right? X cubed?
That's cubic.
Cubic, and that's going to look like it's what happens when you take a paper clip and twist it. Right?
Yeah, it's like it changes direction, kind of.
Yeah.
Changes like that. It's got a turning point or like at the origin. Yeah.
Yeah, and that's called that bit there is called a. I'll introduce you to some of this terminology now. Not only is it called a root or an x-intercept, but it's also called, okay, now this is worth remembering, a point of inflection.
Okay.
Either spell it with an X or with a CT. Point of inflection or a point of inflection. Got it?
Yeah.
Now, this is called a or an x-intercept. But it's also called a vertex, right? Or a turning point.
Okay.
Got it?
Yep.
Okay. This is called a
Root
or an x-intercept. Yep. And that's all it's called. Got it?
Yep.
Now, it's called a root or an x-intercept because it passes through the x-axis.
Yeah.
Okay? This is the
What?
inflection.
Root, intercept, or point of inflection.
Yep. And this is called a turning point, right?
Yep.
Now, when it comes to x to the power 4,
Isn't that still a parabola?
no, it's not a parabola. It's called a quartic. Okay? Quartic.
No.
Called a
Doesn't it
quartic.
still look like? Well, doesn't it still look like a parabola?
Yes. It still has the kind of, there are things about the shape of a quartic that that look like a parabola, but it's not a parabola.
Okay.
So it's kind of going to look like this, right? And it's going to be a lot steeper than this parabola.
Yeah.
But what makes it a quartic is that this power is
4.
or what makes this a parabola is that this power is
2.
not the shape, right? The shape
What?
doesn't make it a quartic or a,
Apart from making it steeper, does the power make any major difference? Apart
Yes.
from steepness. Okay.
yeah. Because what's 3 squared?
9.
What's 3 to the power of 4?
Oh, what's 27 times 3? Oh yeah, 81.
Yep. So by the time you get 3 places to the right, you've gone 81 up.
Okay, so it's a lot. Yeah.
Yeah, it's a lot steeper, isn't it? Yep.
Okay.
With this graph, by the time you go 3 across, we're only going.
Yeah. Okay. So you
Yeah.
get real. So by the time you get to like 8, you've already got like massive values.
That's right.
Okay. That
Got
makes
it?
sense, Yeah.
Okay. Now, here's something that I want you to know. Oh, before I do that, okay, what's this called?
The root, x-intercept, or turning point.
Yes, a root or an x-intercept, or a turning point. Yep.
Is it not a vertex anymore?
No, you're very good. It is also a vertex.
Okay.
Okay. Now, while this vertex is a bit pointy, this vertex, in comparison to the whole curve, is going to be a little bit flatter. Okay. So between -1 and +1, it's going to be flatter than this curve, but outside of +1 and -1, it's going to be a lot steeper.
All right.
Now, here's what I also want you to get, okay? If power is even, right? If the polynomial has an even power, right? It starts and ends on in the same direction, okay? Or in the same end. So if this one's pointing up, this one's pointing up. Does that make sense? So x to the power of 4. If this one's pointing up, this one's pointing up, because that's what the even power tells us. Got it?
Yeah.
An odd power tells us if this one's going up, this one's going down. This one's going up, this one's going down. Okay? Or vice versa. If this one's going up, this one's going down. If this one's going up, this one's going down. Does that make sense?
Yeah.
Okay. Now, the other thing I was going to say is, so the number of turning points will be a maximum of whatever the power is -1. Okay? Let's have a look at some of this. Okay? If you were to graph each of these graphs, right? This one would be a straight line. This one would be a
parabola.
And this one would be a
cubic curve.
Yep, and this one would be also a cubic, right?
Yeah.
Now, all straight lines kind of look like that, okay? Or some variation of that. Either has a negative gradient or a positive gradient. Got it?
Yeah.
Parabolas will have one turning point, okay, or one vertex. Yep.
Yeah.
Okay. All cubics will have two turning points. Okay. 1, 2, right? And it will have one point of inflection, right? Now, what do I mean by a point of inflection? By point of inflection, I mean it's where the concavity changes, right? Can you see that the concavity is changing?
Yeah.
Going from concave down
Here,
to concave up.
it's concave down. After the point of inflection, it's concave up. Got it?
Yep.
So all cubic curves have at least one point of inflection, okay, or two turning points. And the reason why a cubic curve, like a perfect cubic curve, doesn't have two turning points is because what's happening is that this turning point, as this one goes up and this one goes down, right, they're getting closer and closer to the point where it's equaling the point of inflection. Does that make sense?
Yeah.
So this one's moving this way and this one's moving this way to the point where you miss out on the turning points. Okay? Anything that is a polynomial to the power of 4, okay, has a highest degree of 4, right, will actually do this. 1, 2, 3, right? So the number of turning points will be 1 less than the power. Got it?
Okay.
Yep. And the reason why a perfect quartic, right, which is what we had before, which kind of looked like this, doesn't, is because what's happening is these points are getting closer and closer together until it becomes like a perfect quartic. Does that make sense?
Yeah.
So if you had a polynomial that was to the power of 5, right? So just say you had Px was some polynomial to the power of 5. Okay. What would that look like? How many turning points would it have? Anthony?
Oh, to power 5, yeah, 4.
It would have
4.
4. Okay. So it would look like this. 1, 2, 3, 4. Got it?
Yeah.
1, 2, 3, 4. Right? And how low it goes at different, or how high it goes at different points would all depend on the coefficients. Does that make sense, guys?
Yeah.
Yeah. Reef, does that make sense?
Yeah.
Yeah.